So now we're going to look at the other type of multiplication. This is not scalar multiplication, but this is matrix multiplication. It's where we're taking one matrix and multiplying it times another matrix, okay? First of all, it is not commutative. That's really important to remember. A lot of multiplication with real numbers is commutative, but matrix multiplication is not commutative, okay? Second, they don't have to be the same size, but here's what has to happen. If you have, let's see, I don't know how to write it. Well, we'll just write it the way the book does. If you have a 2 by 3 and you're multiplying it by a 3 by 3, these two have to be the same. Okay? So the columns of the first matrix has to equal the number of rows in second matrix. Okay. If they're not, then you can't multiply them. Okay. Now, I usually like to give students an extra piece of information. The outside numbers, that will be your answer. Your answer is going to be, so if you have a 2 by 3 times a 3 by 3, you're going to get a 2 by 3 in this case, okay? So let me go over that again. Your answer will be number of rows in first matrix by the number of columns in second matrix, okay? So let's say you have 1 by 4, and you're going to multiply that times a 4 by 2. I'm sorry, 4 by 2. Well, those are the same, so you can multiply them. Your answer is your product. Your answer will be 1 by 2. It'll be 1 row by 2 columns. Now, that part probably seems really confusing to you, but don't worry about it because it will naturally occur when you go to do the multiplication. You'll realize why it has to be this way. So don't spend a lot of time, memorizing that, but it's good to know. You can keep it as a guide, but you'll know when you go to multiply them, once you get the hang of multiplying them. Okay, so properties. Matrix multiplication is associative. So if you have A times B times C, these are all matrices, then that's A times B times C. So it doesn't matter how you associate them. It's not commutative, but it is associative. And you can also distribute. Oops. So if you have A times B plus C, that equals AB plus AC. And then you can do it the other way. If you have AB, A plus B times C, that's going to equal AC plus BC. Now it's important that we write those both out because it's not commutative. Multiplication is not commutative. Okay, so you have to do them in that order. Okay, so now let's get to the heart of how do we multiply these things. Okay, so let's start out with a little one. Let's say we have, well, I guess a medium-sized one. Let's have a 2 by 3. So A11, A12, A13, A21, A22, and A23. Okay, so that's going to be our a 2 by 3 matrix. And then let's have a 3 by 3. That's what we were talking about before. So it'll be B11, B12, B13. And for our purposes, these are usually going to be real numbers. But we're just using the notation to say, it could be any entry. and it might help to see those subscripts. Okay, so here's what you do. You're going to take the elements in the first row times the elements in the first column, and you're going to match them up, multiply them, and add them together. So that probably sounds confusing, but I'll write it out. So to get the first entry, A11, you're going to take A11 times B11 plus A12 times B21, A plus A13 times B31. Okay, so you're going this times this, this times this, this times this, and you're adding those together. That's just the first entry, okay? Okay, so that's what you do. My teacher used to say you strike the row and the column. That's how you're lining them up. That's why they have to have the same number in the elements in the row as they do in the column. Otherwise, you couldn't match them up. Okay, so we'll try the second element. Okay, I'm going to go to a different color. So A12. You're going to take the first row times the second column. So that's going to be A11 times B12 plus A12 B22 plus A13 times B32. Okay, so you're looking at this times this, this times this, this times this. So a lot of arrows in there, so it might be confusing, but you'll get the hang of it. It takes a little while to get the hang of it. Okay, so then we're going to do the last element, which I'm going to kind of run out of room here, but I'll try to squeeze it in. So we're going to say A13. So we're talking about the first row times the third column. First row times third column. That's what we're talking about right there. And so what do? You go A11 times B13. Okay, so I'm striking the row and the column plus A12 times B23 plus A13 times B33. Okay? That's the first row. Now we have to do the second row. But we're going to do the same thing. So we're going to say, what is the second row times the first column? So that's going to be A21. And that's going to be A21 times B11 plus A22 times B21 plus, trying to make it a little bit smaller, A23 times B31. Now you can look for patterns. You'll notice that these B elements are staying the same, but the A elements change to the new row, okay? So that might be helpful to look for patterns. And I've done enough matrix multiplication, I just know how to train my eye to look for it. Now I'm going to go A22, and that's going to be the second row times the second column. So it's going to be A21, B12, plus A22, B22, plus A23, B32. And you might see other patterns that help you identify things, but we just have to get the process down, I guess. Okay, and then finally, for the second row, third column, we're going to take the row, second row times the third column. So it's going to be A21, B13 plus A22, B23 plus A23, B33. Okay? That's how you do matrix multiplication. Okay? So you have 6 elements. Your final answer is going to be, you're going to have A11, A12, well, let me color coordinate it for you. you're going to have A11 and A21, and then you're going to have A12 and A22, whatever those turn out to be, and then A1, whoops, didn't switch, A13, A23. Now that is the process. It's a little bit hard to show you with the variables, but that might be a good guide for you to use later on. Okay? In the next video, we'll have some actual numbers, and it might be easier to see what's going on. We'll see.